Side of today's activity are problems that all sort of ask you to do what? What was in common to all the problems on the front side, 1 through 4? Yeah. Order of operations, thank you. Right. So each of these problems calls upon you to use the order of operations to simplify an algebraic expression. So that's what the first 4 problems had in common. Then problems 5 and 6, let's take a quick look ahead at those. They were similar to one another, and what are you doing here? So for each of the problems 5 and 6, you're given a value for x, for example 7, right? And then your job is to figure out whether that value of x is a solution of the equation that you're given, right? Which requires, as Christina says, for you to take that value of x, put it into place in that equation, and then evaluate the expression that's on the left side and the expression that's on the right side. And in each of those cases, you're going to again go back on the order of operations to do those evaluations on the left side and the right side. And how are we going to know, in problems like this one, that a certain number like 7 is a solution? What are we looking to happen here? Yeah.
Just make sure it equals whatever that number is.
Exactly. We just need to make sure that after we evaluate this expression with that number 7 in place of x, that the quantity on the left side of the equal sign and the quantity on the right side of the equal sign are the same. Right? That's what it means to be the solution of an equation. It means that the quantity on the left side of the equation and the quantity on the right are identical. So let's look at just a couple of representative examples of each of those problems, and I won't solve all of them, so that those of you that haven't worked on this yet can do a little discovering of your own. So on the first page, let's pick on question 3 for a minute. So question 3, evaluate 5 times the quantity 1 plus 3 squared. Somebody that worked on this problem in the back 2 rows, talk me through your process. What did you do to evaluate 5 times 1.3 squared? The first thing that you did here was to look inside the parentheses. Why? Yeah, well, that's when you first learn how to do this stuff, you learn a scheme, basically, to understand what is meant by an algebraic expression that we write down like 5 times 1 plus 3 squared. There's a lot of different kinds of arithmetic happening here. There's an addition happening, there's a multiplication happening, there's an exponent happening, and there's also these parentheses that are grouping together a portion of this expression. So how do we know what part to look at first? Well, yeah, so exponents are something that we're always going to look at before what? What do exponents come before? So exponents we're always going to think about before we multiply or divide. So basically it means simplify all the exponents that you can before you do any multiplication or division. And we want to get all of our multiplication and division done before we do what? Adding and subtracting, right. Addition and subtraction. So these operations are listed in order of what's called precedence. Which of these operations get done first? Because in a way, we're doing the operations from the most sophisticated down to the most simple. Addition and subtraction is the most simple kind of arithmetic that exists in mathematics. And so we do all the complicated things before we do the simpler things. Anything that we can do with a more powerful operation, we do first. And only after we've exhausted all the exponents do we worry about multiplying or dividing. And only after we finish multiplying and dividing do we do the most basic thing at all, which is addition and subtraction. But you told me that the first thing we wanted to do was to add 1 plus 3. Why are we adding first in this problem?
It's in parentheses.
Yes, right. So the whole purpose of parentheses is to subvert this order, right? If there were no parentheses in our expression whatsoever, this is what the order of operations would look like. Do all your exponents, then do all your multiplication and division, then do all your addition and subtraction. So parentheses are our tool for communicating, I want to do some addition first. Or I want to do some multiplication first before I do some exponents, right? The only way to communicate that is to use parentheses to group. And in evaluating an expression with the order of operations, we look at the innermost parentheses first, and we work our way out. Right? So here there's only one set of parentheses, so there's not really a decision matrix involved in figuring out which parentheses to use first. But you can envision a world where we have a more complex expression that has different sets of parentheses in it. And in that case, we want to go to the innermost one first and work our way out. But for here, it's because 1 plus 3 is grouped in those parentheses. We want to finish all the arithmetic inside those parentheses first, and then worry about moving outside. So when you add 1 and 3 together, you end up with a 4, and our expression looks like this. Now my question is, well, we still have parentheses here. How do we know what to do next? Now the only thing the parentheses are doing are kind of separating that 4 from the exponent that's next to it. But there's really nothing else going on inside those parentheses that we haven't already simplified. So at this point, the parentheses are kind of optional. Right? They're not really grouping anything that wouldn't otherwise just already be grouped anyway if the parentheses weren't there. So once the thing inside the parentheses is just a single number, or a single variable like x, the parentheses don't really need to be there anymore. So once we've finished simplifying what's in the parentheses completely, then they don't really serve a purpose for us anymore. And now the parentheses are gone. What's the next thing I want to do? Taking care of the parentheses, and so exponents. Because at this point I have a choice. There are two operations. I have multiplication of 5 and 4, and then I have the exponent, 4 to the exponent 2. And so it's a very common error when you're working quickly and not thinking about the order of operations. It's a very common thing to kind of read from left to right and say, oh, 5 times 4, let's multiply 5 and 4. Don't read expressions from left to right, unless those expressions all have the same type of arithmetic everywhere. Right? If it's all multiplication, 5 times 4 times 2, okay, fine, read from left to right. But if I have two different types of arithmetic, always think order of operations. What's the operation that takes the highest precedence between multiplication and exponents? It's exponents. So we got to do this, 4 to the power 2, first, and then multiplication second. What is 4 to the power 2? Why is it 16, by the way? I heard somebody say 16. By. Yeah, right. So remember, what does an exponent mean? It means to multiply that quantity by itself however many times. Okay? So raising something to the power 2 means multiplying a 4 and a second 4. Right? 2 copies of 4 multiplied together. So 4 to the power 2 gives me a 16. It's also a very common error when you're working quickly and your wits aren't about you, to accidentally write 8 for 4 squared because you're thinking 4 times 2. Right? But anytime you see an exponent, catch yourself. It means multiply by itself. But then once the exponent is gone, now there's only one thing left to do. Multiply the 5 and the 16.